There we go. Complex fractions. What's a complex fraction? Anybody know what a complex fraction is?
It's a fraction that's complex.
It's a very good answer. That's a complex fraction. What do? We got to simplify this. Think of trig proofs. What would you do in trig proofs if you had fractions? Make a common denominator for the top group and the bottom group, right? You want to make them into a single fraction. So what's the common denominator for the top? 12. How do you get there? You multiply this by 3, by 3, by 3, or sorry, by 4, by 4. So you get 4 over 12 plus 3 over 12. What's the common denominator for the bottom? 8. So we just multiply this one by 4 by 4. And obviously, if you can do this in your head, you don't have to show all the work. Now you have a common denominator, so you can add the numerators. So the top becomes 7 over 12. The bottom is 5 over 8. And then you flip the denominator and you multiply. So you get 7 over 12 times 8 over 5. Then you simplify. So I would simplify before I multiplied them out. I would go 8 and 12. 4 goes into both of those. So the 8 could be written as 2. And this would be a 3. So I get 14 over 15. That's a complex fraction. Easy. Simple? Yeah. Okay. One over a minus 1 over b over 3 over ab. What do we do? Common denominator. What's the common denominator for the top? AB. So I multiply this one by A on top and bottom, and this one by B on top and bottom. Why do you multiply top and bottom by the same number? It's what? Because yeah. Because it's 1, right? 3 over 3 is 1. 4 over 4 is 1. And if you multiply by 1, it doesn't change anything. That's why you do it. So we get B minus A over AB over 3 over AB. Does anybody know why, when you're dividing fractions, you flip and multiply, other than your math teacher told you a long time ago? There's actually a reason for it. Yeah, but why do you? It's because you don't want, they don't like fractions stacked on each other. So we want to clear this one. So what we do is we multiply by its reciprocal. The reciprocal would be A over B over 3, right? Because then those all cancel. But same rule, we multiply by A over A here. So what I do to the denominator, I have to do to the numerator, which is essentially just flipping and multiplying. That's why you do it. The AB's cancel, and you get B minus A over 3. All right. Okay. Let's 2 more examples. Here we'll do. I want restrictions too. Okay, so let's just. What restrictions can you pick out right away? So yeah, if we look at this, x can equal. Thank you very much. Plus or minus 5. So x cannot equal plus minus 5. What else? Is there anything else right now? We can wait because that one's got our negative 5 as well, or a 5 there. So, okay, so then we flip them, right? So we go 2x plus 1, x squared minus 25 times x minus 5 or 4x squared minus 1. What happened? Now that's in the numerator or the denominator. So that can't be 0 either, right? So you could just go 4x squared minus 1 is not allowed to equal 0. X squared is not allowed to equal 1/4. That means x is not allowed to equal plus or minus 1/2. So there's your restrictions. Boom. Now we simplify. X squared minus 25. What does that factor to? Yeah. So I get 2x plus 1 over x plus 5, x minus 5. What about 4x squared minus 1? Does that factor? That's a difference of squares as well, right? So that's 2x minus 1, 2x plus 1. So then you just start slashing. Gone, 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 gone. And you're left with. If you cancel everything in the numerator, what is left up there? Thank you. And that is your answer with your restrictions right there. Are we good with that? All right, one more question. You're going to love me so much for this one. We'll do it in blue. It might make you sad. Sine over cos plus cos over sine over tan over secant. Does anybody want a Math 12 formula sheet? If you remember them, that's awesome. Does anybody want one for the identities? I'll give you one in class.
The very top thing, like I feel like everyone would know by now.
don't need it, but
I saw Miles over the weekend.
yeah.
Torsten was his comp 2 prop as well.
Oh, really?
Said he was really good.
He is.
In terms of cosas and sines, or
We'll write it both ways.
cotangents and cosines?
All right, are we ready? Are we ready? Here we go. What's the first step? So change the tan and the secant to sine and cos and make a common denominator up the top. That's what I would do. So there's that. I made a common denominator, so sine I multiply by cos. That gives me sine squared plus cos squared over cos times sine. The bottom, I changed tan to sine over cos. And secant is 1 over cos. So it looks like a nightmare, but it's all going to clean up nicely. Because as soon as you see sine squared plus cos squared, that equals uno. What do you do? Ignore, then you're kind of done with that. What do you do with this? Yeah, so you're going to flip them, and then you're going to get the cos. You're going to flip the cosine up. Cos over 1 times sine over cos. Cosines cancel. So now I've got 1 over cosine over sine. I get that. And over sine really means sine over 1. Okay? Then it's just fractions stacked. You flip and multiply like that, which is sine times sine is sine squared. So you could leave it like this. That's an acceptable answer. 1 over cos times sine squared. Or you can write it like that. 1 over cos times 1 over sine squared, which is the exact same thing. Or what's 1 over cos? Secant. What's 1 over sine? Cosecant. So 1 over sine squared is secant squared, or cosecant squared secant. I know people love the trig stuff. This is what makes trig hard, is because there's 30,000 different ways to write every question. Okay? All right. That's it. Let me stop this.